All right, let's get going. Good morning, everyone. I'm Matthew from Dental Axess. Thank you for coming along to this webinar of Is Milling for You? Some of you may know me already. I'm the Technical Product Manager at Dental Axess, and I'll be talking today about milling. So, is milling for you? Topics we're going to cover, first up is milling versus grinding, a subtlety that's worth discussing. Also, what to consider when purchasing an in-house mill. Then what are the benefits of in-house milling, how you can achieve shorter turnaround times with your mill, and how to get full flexibility with an in-house milling system. So first up, milling versus grinding. I've got some lovely stock photos on the right of screen, and you can see that milling is a chiseling action. So just like when you have a hammer and chisel and you're going away at a wall, you take away a small flake, and then a small flake, and then a small flake, and on and on and on. This is a lot like what a milling tool does. The milling tool spins, and you move across the material, and the material will cut away and flake away. You can do this for all materials except glass ceramics, because obviously glass would chip if you chiseled at it. You think of your window or your car windscreen. If you went at it with a hammer and a chisel, it would fracture everywhere, and you wouldn't get an accurate cut. Milling can also be wet or dry. So for something like zirconia, you mill it dry. Wax, PMMA, you can mill wet or dry depending on what your mill is, depending on a particular material. Some PMMAs and other plastics prefer to be milled wet because of the chemical makeup of the polymers. Then we think about grinding. Grinding is a sandpapering action. So for glass ceramics, having that glass element, you want to rub away with an abrasive surface and slowly remove layer by layer until you get the shape you desire. You can also do this for some hybrid materials such as veterinamic, depending on which mill you have. Whether you've got something like a DWX4W, you can grind this fairly quickly, whereas veterinamic, you can also mill it, but it takes a lot longer because of the nature of the material. So we prefer to grind something like veterinamic, and we always grind glass ceramics. So next slide, what to consider when purchasing a mill. We've got to look at 5 things. These are the 5 things we always discuss with any person that we meet talking about milling. And the first thing is the indications. What indications do you want to mill? Crowns, inlays, splints, dentures, metal, abutments, all these different things you can mill. Which of those you want to mill and regularly will lead to the indications and what you're going to choose. So for each indication, you have to have a different level of precision. If you're milling an inlay, you want this to fit very nicely. If you're milling a splint, you don't need quite as much precision because it's going to be a removable appliance that wears eventually. So this will lead to the motors in the machine. So do you have linear drives, which are magnets and they're non-contact, or servo motors, which is kind of like a clock where the motor ticks around? One is quite expensive and very accurate. Another is more economic, but not as accurate. All these factors are all defined by what indications you want to mill. There's also the robustness of a machine. You could buy a mill for $5,000, but would really only be good for milling wax because it might be a bit flimsy. Whereas if you go to $100,000, you'll be able to mill metal repeatedly. That also leads into the spindle, and we always measure the spindle's power in kilowatts. Sometimes you have 1 kilowatt, half a kilowatt, 2 kilowatts. And again, this depends on what indications you're going to be milling. If it's again only wax crowns, then you can have quite a relatively low power spindle. But if you're going to be doing a lot of metal, you need a high power spindle. Also, the indications will determine your CAM software. So again, wax crowns, it's a fairly simple milling job. You don't need an overly complicated or expensive CAM software. Whereas if you're going to be doing a lot of metal implant bridges where you need drill holes, you need that perfect fit for the implant, we need a more expensive CAM software with more capabilities so we can really refine, say, a conical multi-unit or any shape we use. This ties in quite closely with the materials and the indications, of course. Is it just wax, PMMA, and zirconia? Are you venturing into titanium or cobalt chrome? Are you doing glass ceramics as well? Each of these things need to be considered not just for the strength and cost of the mill, but also Any cleaning, so wax is pretty easy, you just vacuum it up. PMMA, it might stick to everything because of the electrostatics involved with cutting PMMA. Titanium, you have to have a mill that has some coolant, and you're going to get all these titanium swarf or shavings that will end up in the mill that you have to regularly clean off. Or glass ceramics. I've listed glass ceramics on its own because of the chemistry of the lithium disilicate. It loves to stick to metal. If you've ever seen a machine that mills a lot of glass ceramics, you'll notice that you have to be really, really vigilant with the cleaning. So that's another thing to consider when you're purchasing what materials and what sort of maintenance and cleaning is done half daily, weekly, and so forth. Also, what do you have to consider? The volume of milling you're going to be doing. So are you going to be doing 3 crowns a day or 3 crowns an hour? Is this going to be once a day or 10 times a day? So you have to think about what your machine can do all the time. Something like a Roland 52 DC, which I've got in this picture here, this can mill some PMMA, but if you're going to be milling PMMA for 20 hours a day, 300 days a year, then maybe consider a mill which is better suited to milling PMMA. So that's where we talk about volume. Also redundancy. If you're going to be investing in milling, you need to be able to think about redundancy. Machines will break. Any machine will break, unfortunately. So you need to think, one day I'm going to have downtime, and what's my redundancy? Will that be a duplicate of the same machine, or another machine that can part-time mill my other indications, or do I outsource for redundancy? You've also got to think about milling time. If you're milling heaps of zirconia copings, then you can mill these quite quickly. But if you're going to be milling a titanium framework, then that's going to take a bit longer. Which machine is faster at doing which milling jobs? So you have to think about milling time, how this affects your other workflows in your lab or clinic. Also, your expansion options, so scalability. If you've already got one brand of mill, then adding that same mill a second time is a very small increment in terms of the learning required. You just have to make space on the bench next to it. Whereas if you're going to scale to a much bigger mill, you might have to learn possibly new advancements in CAM, new interfaces with the newer, bigger mill, think about other considerations such as noise. So discussing these future-proofing ideas is always good to do. Also your workflow integrations. What CAD software are you using? Can that link in easily with your mill? So if you have something like the Trios Design Studio or Exocad Chairside, these already link in with the mills like the Roland DXX4W, IMES iCore CoreITech 1, and other small mills. Also the CAM, what information comes across into the CAM that can help you get a good milling result, such as XML data for reading the margin line or the implant drill holes. Also indication recognition. If you send in a splint and a crown and a hybrid abutment for a tie base all into one job for PMMA, can your CAM read all of these and know how to mill each indication differently all in the same job? So something to consider is which CAM software you're using. And also automation. So say you've got this Roland 52 that we see on screen. It has a robotic loader on the left side, so it has 6 changes. When you finish milling one job, it will automatically change over to another puck, bring that in and start milling. So this can run effectively 24 hours a day. All you just have to do is make sure there's enough material in there to mill what you want. This has a barcode on it, so the machine will scan up and down and say, okay, where is number A or C, whichever I'm milling. Grab this and load it in. Also, this can go hand in hand with inventory management. If you're milling with a robotic loader and you've got, say, 2 wax pucks and then 4 zirconia pucks in shades A, B, C, and D, you can quickly see, oh, I'm running low on my B shade because I've almost finished that block. So considering these things, and this often goes hand in hand with expansion and future-proofing, what you're going to do now and what you may be doing in a year or two's time. So what are the benefits of in-house milling? The main one, I think, is the most important, is total control over materials. So you can choose the brand of zirconia. Some outsourced milling centers may bulk buy their zirconia from somewhere that you don't necessarily like the zirconia of. It may be the shade, it may be the manufacturer, it may be the chemistry, a bunch of other factors. But when you mill in-house, because you load the block in, and you've obviously purchased that block yourself, you know exactly which brand you're using. This can also go with shades. So if I bring in this next image here, I've loaded into Mailbox the exact same crown twice, and I've chosen to color my block with some arbitrary colors just for demonstration. But you can see here I've shifted one block near to the top of the crown, and I've left the other in the middle. Then you can see I've got some colored bands to show maybe where there's a graduation in color through the block. Having total control over your materials, you can rotate and shift your indications within the block to get the exact shade you want. If it's for a posterior, maybe it doesn't really matter, but anterior aesthetic work, you may want to get an exact shade. Maybe you want to tilt the crown, so if it's a central incisor, you want to have the shade curving down the front, or maybe you want to tilt it up so it's a different graduation. Again, doing this in-house, you have complete control over this. Also the sprue location. Some people don't mind if there's a sprue on the lingual side, they'll just polish it off. Other people don't want the sprue in the mesial and distal contacts. Doing this in-house, you again have total control over all these factors. What other benefits are there? Oops, too far. My slides have been jumped out of order. Apologies. What else to consider is there's the choice of finish quality. So this image at the top here, you can see there's a whole lot of milling steps, and the one I've highlighted is the use of a 0.5 millimeter tool in the occlusion only. Some people will say, I don't need the 0.5, I'm happy with a 1 millimeter. Say it's interior work, the shape may not need it. Or if it's an elderly patient, you may not want huge amounts of detail on the molders, which just can become a food trap. Going the other way, we've got some customers who love to use a 0.3 millimeter tool, really tiny. You can use this to get really lovely detail on the occlusal surface, or you can even use it to get a really sharp margin line if that's what you desire. You can also choose the brand and type of tool. So these two images I have on the bottom of the screen now, they are scanning electron microscope, SEM images of a tool from the supplier we use, and you can see they're actually diamond coated. When you look at your zirconia tools, you'll pick them up and say, oh, these have a black coating. That's actually a diamond coating. If you look really closely at this image, you can see there's a scale bar at the bottom of 5 microns, and you can see all the diamonds. So they are diamond coated for hardness, but not for the way a diamond ring is diamond, for shiny and lovely glittery. So choosing which tools you use and what coating they have, which manufacturer, you can again have total control over this. Also, you can get a faster turnaround. Say you want to not bother with the 0.5 millimeter tool for the occlusal milling, you can save maybe a minute for the tool change, 30 seconds for the milling, and then another minute for the tool change again. So you can quite easily cut down the milling time by 10 to 15% very easily, or even more if you want to choose a certain level of detail. This also goes hand in hand with outsourcing. Unless there's a lab down the road that's milling for you, and you can walk there or drive there and get the indication back, you can have your machine mill you a crown in 25 to 30 minutes or so, depending, again, what options you choose. So this can mean that you can get a job scanned in the morning, mill it during the day, and then post-process in the afternoon and return it. This is obviously leading to the chair-side same-day dentistry. So these are other things to consider: how fast your mill is, what turnaround times you want and desire. So to achieve these faster turnaround times, we've spoken about surface quality. Is it really worth doing that extra 5 minutes of milling for something that you may buff away or polish away, depending on what material you choose? Say you get a PMMA, you can have the most amazing detail, but if you go over it with a pumice or a high shine, you may buff that detail away. So these are things to consider: what material you're going to use, what surface finish you're going to use, and what post-processing you're going to use. This will help you get a faster turnaround time. Also, post-processing. So obviously zirconia needs to be sintered. Some firing cycles are 3 to 4 hours. Other firing cycles, say for a full arch zirconia bridge, are 8-9 hours. So that has to be either started at 8 AM and finished at 5 PM, or you hit go at 5 PM and it's ready the next morning. Other materials, such as Emax and other glass ceramics, all they have to do is be fired. That can be a much quicker process. Or PMMA or some other hybrid materials, all you have to do is polish. So thinking Which material am I going to choose? This can greatly affect your turnaround time. Do you outsource your milling? Do you outsource your sintering? Or do you outsource the milling but then sinter in-house? All these things affect the turnaround time. And then your tool choice. If you've got a larger mill, such as an IMES 350 or 650, you can do the roughing of PMMA with a big 4mm tool that can just rip through material. Or if you're milling metal, such as titanium, you can get a Quattro tool, which moves twice as fast around and takes twice as bigger steps. So that's something to consider. You can get a lot quicker milling results if you have a big enough machine. Also, do you do the milling and the roughing steps with a 2mm ball or a 3mm toric? Due to the shape of the tool, you can save a lot of time in the roughing. This also leads to the finishing. Again, what post-processing are you going to do? Is it worth spending all that time getting a lovely 1mm finish on, say, a bite splint, when you're going to get it and polish it anyway? So you could save 20 minutes there for a maybe 2-hour process, which is quite a significant amount of time. Next up, getting full flexibility. Optimizing the use of in-house and outsourcing. I've got an example here of someone may have purchased a dry mill, and all they do is zirconia, PMMA, and wax. They start doing a bit more implant work, and then demands asks them to do titanium bars and hybrid overstructures. They're not going to go and invest $100,000 in a titanium mill when they can outsource it to a lab down the road. Say only 5% of their jobs are metal. It's not worth doing this in-house. You can outsource. Or say you've got 10 crowns that you need to mill now, individual crowns, but you've also got a full arch job that you want to mill also by tomorrow. Why not outsource the full arch job to a milling center down the road and have them courier it to you the next morning? That way you've made use of your mill and theirs, even if it's for the same material. So balancing the choice of in-house and outsourcing to really get full flexibility. Also, workload scheduling. We have a lab that talks about how they schedule their work. They'll mill all the wax during the day, so they'll start that at 9 AM. It'll be finished around lunchtime. Then they can take the sprues off, do any further refinements they want by hand with the wax, and then they press in the afternoon. And then they mill zirconia overnight, which can take a bit longer because it's a slightly tougher material. It takes longer to mill the same volume. That way, it's done overnight. They come in the morning, and it's ready for sintering in the morning. Then those jobs are sintered by the end of the day, and they can give them to the courier. So working out how I'm going to schedule using one mill to do different materials. Also utilizing the loader. I spoke before about, say, the Roland DWX52. It has 6 loaders or loader slots. Some people put a shade of zirconia in each one. That way you don't have to spend time undoing the holder on each block. You don't have to spend time finding these in a shelf, going, where are my blocks? I've lost them. They're already loaded in the machine. That way you can have full flexibility of color and shade, different materials, different heights, different manufacturers, and they're already loaded there for you. You don't have to go and hunt them out in a cupboard somewhere. So that's the end of the webinar for today. Thank you very much for attending. Of course, if you have any questions or you want some advice on which mill might be the right choice for you, or whether you can in-house some things, outsource others, please get in touch with us at denalaxess.com. Follow us on all the social media, give us an email, give us a call. Any questions, reach out. Thank you very much. Bye.